Hey there guys, today we're talking about 5.2e. I can solve quadratic equations with complex solutions. So just as a review, we've got a graph of a quadratic over here. We know that solutions have another name, they're called roots, and that's where they cross the x-axis. And unfortunately, so far we've said, no, this quadratic doesn't have any solutions. It crosses the x-axis at precisely 0 points. Yeah, it crosses the y-axis, that's great, we don't call those solutions. We're looking at crossing the x-axis. So remembering from our standard form of a quadratic, which is ax squared plus bx plus c equals 0, has nothing left on this other side, everything's all on one side of the equation, we can come up with the quadratic formula. So this is the thing we'll be using the most. And remember, if you don't have this memorized, you better write this down every single time until you get it memorized. So there's this thing called the fundamental theorem of algebra. The fundamental theorem of algebra states that every non-constant single variable underline this and this is going to show up several times, polynomial with complex coefficients has counted with multiplicity exactly n roots, which by the way we also call those solutions or x-intercepts or whatever else. Alright, so what this says is that the fundamental theorem of algebra, I'm just going to read this again, every non-constant, single variable, degree n polynomial with complex coefficients has counted with multiplicity exactly n roots. So here's what this says. Every non-constant that says this is not a single number, single variable, which says we just have one variable in here, just x. It doesn't mean it can't repeat itself multiple times, we just have one kind of variable in here. Degree n, remember this degree for a polynomial is the highest exponent, so for quadratics we have a 2 for a degree. With complex coefficients, don't forget complex have a real or imaginary part or both, which says that we just have regular numbers or complex numbers in the place of a, b, and c, has counted with multiplicity. Well, multiplicity is kind of like multiples, which says that you can repeat the same answer over and over, and that's fine. Exactly n roots, which says that quadratics, because they have a degree of 2, have exactly 2 solutions, which if we're graphing on the standard Cartesian plane, they're not going to show up, and that's okay. We'll talk about graphing the complex numbers in just a little bit. But that's not today. Instead, we're going to figure out how do we find out what these 2 solutions are for our quadratics. So the thing we're looking at, which gives us the problem of either having real solutions or complex solutions, is the stuff on the inside of the quadratic formula as roots. So the radical sign, so the square root up here. And the stuff on the inside has a special name. The discriminant is known as the stuff on the inside, and it is just, not a minus sign, it is b squared minus 4ac. So that's just the stuff, I just copied it down from the inside. And this is called the discriminant, and it has some interesting properties. Because we don't have to look at the rest of this to figure out what the real or imaginary solutions are, we can just look at just this part. That says we're just going to look at just that part. So what we're saying is that if we have the discriminant, and after we simplify it, so we get down to one number, whether it's positive or negative. If it's positive, right, we're going to take the square root or simplify it like we have already, and then we're just going to do whatever we do, and then we get our 2 answers. It might be some decimal or some not as pretty numbers. And then we also can have negative. If we have a negative in here, we now know how to simplify a negative square root using I in our complex numbers. So we can use that to get 2 answers as well. And then we can also have either negative or positive. We have that number in the middle is 0. Anything plus or minus 0 is whatever that thing is. So we're only going to have one solution there. So we're just going to write those down. So for b squared minus 4ac, we've got 3 options. If we get a positive number for our discriminant, which is to say that it is a number that is greater than 0, then we have 2 real solutions. And this is just like the regular kind we've been dealing with in the past, where we get plus or minus numbers, and sometimes it'll be decimals, but sometimes it'll be nice. We can also have a 0, where the discriminant equals 0 is going to give us precisely one solution. and it'll also be real. And then if it's negative, we used to just say, oh, no, we can't do that. Now we're going to say if it's less than 0, if it's negative, we're going to have 2 what we call complex solutions, because they're complex numbers. All right, so that's a lot of writing for one page. It's all notes. We're going to do a couple of example problems on the next page. So, move this over. Example 1, 5x squared plus 10x plus 5 equals 0. So the questions might ask a couple questions. One thing it might ask is, how many solutions are there? And the other question it might ask you to find is, find the solutions. So I'm going to do the more complicated one, which is find them, and that will also walk us through the question of how many solutions there are. So for this equation, we've got everything on one side. We know that A is equal to 5, B is equal to 10, and C is equal to 5. And it's 5, 10, and 5. So I'm going to write down the quadratic formula. So x equals negative b plus or minus square root of b squared minus 4ac, all divided by 2a. All right, let's substitute in. So we have negative 10 plus or minus the square root of 10 squared minus 4 times 5 times 5. Don't forget to bring that square root all the way over. And our division line goes all the way underneath everything. All divided by 2 times a, which is 5. I've got some smearing there, sorry. Okay, so let's do some simplification. Can't simplify negative 10, so we're just going to x equals negative 10 plus or minus. 10 squared is 100, minus 4 times 5, which is 20, times 5, which is 20 again, so, or times 5, which is 100, so 10 squared minus 4 times 5 is going to give us a 0 all over 10. Okay, so we know that if we look at the discriminant, the part underneath the radical, right, then we're going to have, let me focus this, we're going to have just one solution, because if we look back at the last page, we know that if our discriminant, which is the part underneath the radical, is 0, we're going to have exactly one solution. So we know this because the square root of 0 is equal to 0, so we get negative 10 plus or minus 0 all divided by 10, which if we split that, negative 10 plus 0 all divided by 10, and negative 10 minus 0 all divided by 10, we get two of the same answer. Negative 10 plus 0 is negative 10, divided by 10 equals negative 1. Negative 10 minus 0, which is still negative 10, divided by 10 is going to equal still negative 1. So our two solutions are negative 1 and negative 1, and this is one of those cases with multiplicity. Unfortunately, it worked out we didn't have any complex answers in this one. That's okay. I rate the next one to do that. So this is our multiplicity. We have two solutions. Even if they're both negative 1, this graph of this thing is only going to cross the x-axis at precisely one point, which is negative 1. All right. Let's look at the second one. So we're going to do again the same thing. We're going to find the solutions, and in the process we should be able to look at the discriminant and say, oh, this is how many solutions we should definitely have. So the first problem with this one is I notice not everything is on one side of the equation. So I'm going to add 6 to both sides, and because there's no like terms with numbers over here, we're just going to rewrite it as 7x squared plus 8x plus 6 equals negative 6 plus 6 gives us nothing, and that's what we want. We want nothing. Okay, we'll do the same thing again. A equals, B equals, and C equals. So x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Okay, let's see what happens when we plug numbers in this time. So negative b is negative 8 plus or minus the square root of 8 squared minus 4 times 7 times 6. And then our line goes all the way across it for our division. Divided by 2 times, oops, not a. A is going to be 7. Okay, so we're going to do some simplifying. We can simplify this stuff, our discriminant on the inside. So x equals negative 8 plus or minus, let's see, 8 squared minus 4 times 7 times 6 gives me negative 104. All divided by 2 times 7 is 14. So then we're going to simplify this negative 104. And I'm just going to pull this out to the side over here. We'll call it an aside. With an E at the ends. Square root of negative 104, we know this is negative 1 times 104, and we know that 104, I think, is 4 times, let's see, let's quick division, I think it's 21? 26. Wrong again. Oh well. 26. I know I can take the square root of negative 1 and get I can take the square root of 4 and get 2, and I can't break 26 down into the product of a perfect square anymore. So we're going to have 2I square root of 26. So we're going to replace our square root of negative 104 with 2I square root of 26, negative 8 plus or minus 2I square root of 26, all divided by 14. We know there's a negative number. We're going to have two solutions. So I can simplify just a little bit. Because these two numbers have a 2 in common, I'm going to divide by 2 in both of those. So x equals negative 4 plus I square root of 26, all divided by 7. And x also equals negative 4 minus I square root of 26, all divided by 7. And those are our two answers. So basically, we do the quadratic formula like we always have, except this time, instead of saying, oh no, we can't go on because we don't know how to take the square root of a negative number, we just use our i's like we haven't been in the past. Alright guys, I know this is a lot, but I'm not giving you a whole lot of problems to practice, so come get your practice and we'll get going.